Hello, so let's talk about the find if paths exist in graph. So you are given a bidirectional graph and then also the end vertices and also the source and the destination. So you want to find out if there is a path you can achieve from source to destination based on your given edges. And this is super straightforward. So we need to build a graph, right? So build a graph, and then how do we build it? We can create a map, and then the key will be the vertex, right? So I'm going to call integer, and then the value for the map should be what? The list of integer, right? This is because you can connect to other vertices, right? And more important is multiple vertices, right? So we need to build a map. Map is my graph. Then I just traverse my edges. So how do I traverse my edges? I need to push into the queue. So push into the queue, and also I need to keep track of the current visits vertex, right? So I need to have a set to check, do I visit this vertex already? If I do, then I don't have to visit again, right? Or that's why you are in the infinite cycle, right? So this is pretty much a solution. So let me just start writing and then just follow along. So in this one, I'm going to use a set for the visits. So for the map, for the building graph, I'm going to say list map of list and also the list of integer, right? I'm going to call map, and I traverse my edges. I'm going to say u equal to edges 0, v equal to edges 1, and also I need to just construct, right? So since I'm not declare my list of integer inside my map, I need to use a compute if absent. So I'm going to put u into the key and also declare my new array list for the list of integer. And then since I have it, so this will create an empty new array list based on the u, and I just have to add the v. So this is one directional, but since this is bidirectional, right? So just another one, compute if absent v, and then the arrow sign. This is lambda expression, and I just say dot add and then u, right? So this will be the bidirectional, right? So once I have it, I need to have a set for the visit. So say that add the source, right? So how do we traverse? I have to use a linked list. So q, I need to just traverse based on the integer, right? Q equal to new linked list, and I just starting from the source, right? And then I just have to traverse until the queue is empty, right? So while queue is not empty, and then also the current size for the queue. So traversing the size, the current level, the current iteration, and the size minus greater than 0. And I need to pull out the current vertices inside the queue to check do I visit or not, right? So if a current, so just make sure the base is if the current is actually equal to destination, I'm going to return true because I find it. Else, I need to keep traversing for the rest of the connection. But before I go to others, I need to make sure I add a current vertex into the set, and then traverse my neighbor. So it's going to be adjacent. So map.get the current point. So when I say map.get will be the list of integer, and I traverse the adjacent. So if not visits, so if not visits the vertex, I need to add into the queue and also add into the set, right? So which means which means I don't add a duplicate value inside the meta get current, right? So this will definitely exclude a lot of stuff. So if you cannot find it and then the queue is already empty, then you return false. So let me run it, submit. Yeah, so this is pretty much it, right? So let's talk about the time and space. For time and space, for this one, this is actually the time, this is actually the time, right? So it actually V plus E. V represent the vertices, E represent the edges, and then V is 3, edges is 3. So just say V plus E for the time. And then for the space is also the same, right? You want to put the connection into the map, and also this is V plus E. And yeah, this is also space, but the worst case is going to be this one. And this is definitely all of them for the max, right? And represent the the vertices, right? You only add a vertex into here. So this is the solution. So let me just see if I can make any debug. So I would definitely give another solution later. Alright, so this is edges, this is the destination, source destination, and this is the connection, the edges connection based on the build graph, right? And then it's starting from zero, and then keep going. This is not, so you traverse the adjacency, right? So you're still traversing, you're pushing 1, right? And you're pushing 2. So this is the idea, right? And then you keep going, right? Alright, so this is pretty much it, right? So you might be wondering why using a set.add over here. And in the if statement, I using set.add over here. So let me comment this out, and I try to run this first. And yeah, here we go. So they are the same. This is because if you traverse, and then when you traverse, you already add a source at the beginning for the source, and also when you traverse the neighbor, the adjacents, right? You also add, so you don't need this one. So this is pretty much it for the current solution. So let me give you the update one. If you don't want to use in a set, you can use in a Boolean array. So I'm going to call visits new Boolean, and how many you have unsize, right? So again, like you can say visits dot source equal to true, right? And then for the visits, so here we go. So the visits at adjacency, for the visits at, if not visit, you want to push into the queue. So adjacent equal to true right here. So believe it or not, they are the same. Yeah. So just look at the time and space. Look at this. Set actually looks better, right? And it doesn't matter. It depends on the vertices and edges, right? Alright, so the time and space are still the same. V plus E, they are the same. Alright, so if you still have a question, leave a comment below. Subscribe if you want it. And I'll see you later. Bye.